This video will be discussing dividing polynomials. So we will be dividing by long division polynomials, and then we'll be introducing synthetic division, which is another way to do the same thing. The information from this video and the examples come from the OpenStax free college algebra textbook, and the link to that or the website is in this video, so you can see that for reference. So the first example I'm going to do is just long division with numbers. So we're going to use real numbers first to remind ourselves how to do this, because it's probably been a while since you've done long division by hand. And then we're going to use the same process for polynomials. So 178 divided by 3. The first thing to remember is you're dividing by 3, so that goes on the outside, that's the divisor. And then the 178 goes underneath, that's the dividend, and you're going to divide. You start by trying to divide 3 into 1. That doesn't go, so you look at the next one, 3 into 17. And you know 3 goes into 17 5 times. So first you divide. Okay, then the next thing you do is you multiply. So you multiply 5 times 3, you get 15. And then you subtract. So you subtract. So 17 minus 15 is 2. And then you bring down the next number. So we're going to bring down the 8. 3 goes into 28 9 times. 9 times 3 is 27. You subtract, you get 1. So we have 59 and 1/3. So 59 and 1/3. You write the remainder over the divisor. Or you could say 59 remainder 1. Okay, but we're not going to be adding the decimal and going on. We're just going to leave it like that. And we'll do the same process with polynomials. So number 2, this is an example with polynomials. Now, one thing you need to keep in mind when you're doing these is you need to make sure that your polynomials have descending powers. So for example, we have a 3, a 2, a 1, and then we have a constant which doesn't have an x. So that's in descending order. That's how we want it to be. And we also want to make sure we're not missing any terms. So since it goes 3, 2, 1, 0, we're perfect. We're not missing anything. So we're going to go on from here. So for long division, we're going to be dividing x plus 2 into 2x cubed minus 3x squared plus 4x plus 5. Okay, so the first step is to divide. So when we divide, we only want to divide the first term by the first term. So 2x cubed divided by x. When we do that, we get 2x squared, and so that's what's going to go right here. Okay, and so now after we divide, we multiply. So we're going to multiply the 2x squared by the whole divisor. So 2x squared times x is 2x cubed. Okay, and then 2x squared times 2 is 4x squared. So notice that like terms line up under each other. Also notice that the first terms are the same. If these first two things don't match, then you did something wrong, okay? The next thing we want to do after we multiply is subtract. When you subtract polynomials, remember that you have to distribute the negative to the whole polynomial. That means this is a negative and this is a negative. So you distribute the negative to everything on the bottom that you're subtracting. All right, so once we do that, we see that 2x cubed minus 2x cubed, that's going to zero out. Negative 3x squared minus 4x squared is negative 7x squared. And then we bring down the next thing, so plus 4x. All right, so now we're going to repeat. We're going to do the same process. So we're going to take the first term, so this negative 7x squared divided by x, okay? So we'll have negative 7x squared divided by x, and that's going to give us negative 7x. So that's going to go up here, minus 7x. And then we're going to multiply. So negative 7x times x is negative 7x squared. Negative 7x times 2 is minus 14x. Notice, oh, now we have to subtract, right? Notice the first two are the same. When we subtract, we distribute that to both things on the bottom. So now negative 7x squared plus 7x squared, that zeroes out. 4x plus 14x is 18x. Bring down the 5, so plus 5. And now we get to do this again. Okay, so now we have 18x divided by x. So 18x divided by x, that will give us 18. So plus 18 is going to go up here. And now we multiply. So 18 times x is 18x. And 18 times 2 is 36. Now we need to subtract. So that means change the signs of everything on the bottom. 18x minus 18x, those cancel out. 5 minus 36 is negative 31. There's nothing else to bring down, so we're done. Okay, so now how do we write this? Here is the quotient. So all of this in gray is the quotient. And then we have a remainder of negative 31. And that can go over this divisor, just like for our remainder in the previous problem. So our answer, our quotient, is 2x squared minus 7x plus 18 plus negative 31 over x plus 2. Now, in this case, you could have put the negative out front, like you could have done 2x squared minus 7x plus 18 minus 31 over x plus 2, and that would be the same thing. But I always put plus a negative in this case just because if you have a remainder that is more than one term, and you have a negative in the front of the first term, it's going to get messy. Like, you're going to probably do it wrong if you get used to putting the negative out front automatically. This case, it doesn't matter, but it could make a difference if you have more than one term as your remainder. Okay, there is the web address for the textbook. All right, number 3. So now we're going to use synthetic division. So we could do long division, but synthetic division is much more efficient. It's the same thing. So let's go back to this other one. Let's go ahead and try to do synthetic division for this one so I can show you where the pieces are coming from. So here is what we have. Let's see, I will do it in green. Okay, so for synthetic division, what you want to do is you want to use the opposite sign of this. Okay, so the factor is x plus 2, but the 0 is negative 2. So when you're using synthetic division, you always divide by the 0. So the 0 is negative 2. Okay, then what you want to do is you want to simply divide that by the original polynomial. However, you don't want to write any variables. So you're simply going to write the coefficients of each term down here. So the coefficients are 2, negative 3, negative 4, and 5. So 2, negative 3, 4, and 5. Okay? Now what you do is you start by bringing down the first number, and then you're going to multiply, add, multiply, add, multiply, add until you get to the end. So you're going to multiply this negative 2 times 2. So here times here. Negative 2 times 2 is negative 4. So that goes here. Okay? Then you're going to add straight down. So negative 3 plus negative 4 is negative 7. Now you're going to multiply negative 7 times negative 2, and you're going to get positive 14. Then you'll add straight down. 4 plus 14 is 18. Okay? All right, now you're going to multiply 18 times 2. 18 is negative 2, and you'll get negative 36. And then you add straight down, and you get negative 31. I always put a box around my last number because that's my remainder. If you look at the numbers that we got, we have 2 and 2. Notice that that's what we got here. We have negative 3, negative 4, negative 7. Notice that's what we have here. We have 4, 14, and 18. That's what we have here. And then we have 5, negative 36, and negative 31. That's what we have here. So this synthetic division, we're getting the same information, but it's in a shortened way. It's like a shortened way to do it. It's more efficient. People usually don't make as many mistakes, but we're doing the same thing. To write your answer after you use synthetic division, what you need to realize is when you're dividing, you're bumping it down a level or a degree. So our original polynomial was an x cubed, right? It was an x cubed. Our answer is in x squared. So whatever you have originally, you're going to bump it down a level. So since we started with an x cubed, our answer will be, so this is x squared, this is x, this is no x, so it's a constant, and this is the remainder. So our function is going to be 2x squared minus 7x plus 18, and then remainder negative 31. Or write it like we did over here, the remainder over the divisor. All right, so let's look at some more examples of synthetic division. So this next example, we're going to do synthetic division. First thing you want to do is make sure you identify the 0. So the 0 is negative 3. And then you want to make sure you have all of your powers in descending order. So we have x cubed, x squared, x to the first, and then no x. So that's perfect. So we're going to have negative 3 here. And we're going to use our coefficients. So 3, negative 2, 1, and negative 4. So 3, negative 2, 1, negative 4. Bring down the 3. We're going to multiply. Negative 3 times 3 is negative 9. Add straight down, we get negative 11. Negative 3 times negative 11 is positive 33. Add straight down, we get 34. Negative 3 times 34, let's see what that is. 12, looks like 102. So negative 102, we add straight down, we get negative 106. Okay, so remember this negative 106 is our remainder. Since our first term in our original polynomial was an x cubed, that means this is going to be an x squared. So this will be 3x squared minus 11x plus 34, and then remainder negative 106. Okay, so depending on how it asks you to write it, that's one way to write it. The other way you can write it is 3x squared minus 11x plus 34 plus negative 106 over x plus 3, which is the divisor. Okay, so either way you can write it one of those two ways. All right, number 4. So here we have synthetic division. The first thing we want to do is find the 0 associated with our second factor. But here is the key. To use synthetic division, you need it to be a linear factor with a coefficient of 1 in front of the x. So if this is not a 1, you have to divide by something that'll give you a 1. So if you divide by 3, that will make that a 1. So now this will be x minus 1/3, and so the 0 will be 1/3. That's always how you will start out, is making sure you have a 1 in front of the x there. If you don't, you adjust it. Now, you need to make sure that you highlight it or do something to circle it, because you're going to have to adjust your answer in the end by the same factor. And I'll show you what I mean in a minute when we get there. So now the next thing we want to do is look at what we're dividing into. So we have an x cubed, then we should have an x squared, but we don't. It goes to an x to the first. So we need a placeholder. So we have 0x squared. You have to put in a placeholder or it's going to mess up your synthetic division. So it has to be x cubed, then x to the second, then x to the first, and then no x. If you don't have all of the pieces, you've got to add in placeholders. Okay, so I'm dividing by 1/3. And my coefficients are 9, 0, -1, 2. Bring down the 9. 1/3 times 9 is 3. Add straight down. 0 plus 3 is 3. 1/3 times 3 is 1. Add straight down. -1 plus 1 is 0. -1/3 times 0 is 0. Add straight down. 2 plus 0 is 2. So there's my remainder. Again, we started with an x cubed. So our answer is going to start with an x squared. So we have 9x squared plus 3x plus 0. I don't need to write that. And then I have a remainder 2. Okay? Another way to write this is, or 9x squared plus 3x plus 2 over 3x minus 1. Okay, now here's the other thing. That's not our final answer, and I always forget to do this, and I even highlighted it, but that's why I'm bringing your attention to it. I told you we have to adjust by a factor of 3. When we get to our answer, we have to divide everything, not the remainder, everything else, by 3. Okay, if we don't do that, then we will not have the right answer. So again, we're adjusting for having divided by 3 in the beginning. We're going to divide this by 3 as well to even it out. Okay, so now our final answers will be 3x squared plus x, remainder 2, or 3x squared plus x plus 2 over 3x minus 1. All right, so after adjusting, those are our answers. All right, so number 5. Use synthetic division to determine whether the first expression is a factor of the second. If it is, indicate the factorization. Okay, so we're going to be using synthetic division as it says in the directions. So we're going to be dividing by the x minus 2. So the factor is 2. So we're going to be dividing by 2. Then we're going to check what we're dividing into. We have an x to the 4th, an x cubed, and then an x to the 1st. So look, we're missing an x squared. So plus 0x squared. Okay, so now I have 4, 3, 2, 1, no x. So perfect. So I'm going to have 3, -6, 0, -5, and 10. So bring down the 3. I start by multiplying, so 2 times 3 is 6. Add straight down, I get 0. 2 times 0 is 0. Add straight down, I get 0. 2 times 0 is 0. Add straight down, I get -5. 2 times -5 is -10. Add straight down, I get 0. Okay, so my remainder is 0, which means it went into it evenly. If it goes into it evenly and the remainder is 0, that means that it is a factor. The first expression is a factor of the polynomial. Okay, so x minus 2 is a factor of the polynomial. And again, that's because you had a remainder of 0. Okay, so now we're going to write what we got. We started with an x to the fourth, so that means our answer is going to start with an x cubed. So this is going to be 3x cubed, 0, 0, and then a minus 5. Okay, so remember that this is an x cubed, this is an x squared, this is an x, and then the last thing is a constant. So there's 0x squared and 0x. I don't have to write that. And then, of course, the remainder 0, I don't write that either. So this is what we got for the quotient. Okay, so this is the quotient. It asks us to indicate the factorization. So what they want us to do is say the function is x minus 2, which is a factor that was given here, times 3x cubed minus 5. And the 3x cubed minus 5 won't factor any further, so we're just going to leave it there. So that would be what we would write. Okay. All right, let's look at the next one. Number 6. So same directions. So first of all, our 0 is 2. Now we're going to check our degrees. So we have our exponents. We have 3, 2, 1, no x. So perfect. We don't need any placeholders. So now we're going to divide by 2. And our coefficients are 4, negative 3, negative 8, and 4. So bring down the 4. Multiply 2 times 4, we get 8. Add straight down, we get 5. Multiply 2 times 5, we get 10. Add straight down, we get 2. Multiply 2 times 2, we get 4. Add straight down, we get 8. Okay, so that means this is not a factor. X minus 2 is not a factor of the polynomial given because there is a remainder other than 0. So if there's any remainder other than 0, it's not a factor. So x minus 2 is not a factor of the given polynomial. And so that's all we have to do on that one. We don't have to write the factorization because it's not a factor. Okay. Number 7. Use the graph of the third degree polynomial and one factor to write the factored form of the polynomial suggested by the graph. The leading coefficient is 1. Okay, so this, we want to be able to pick out the factor. So the factor from the graph is associated with the 0. So there's the 0. The 0 is negative 1, so the factor is going to be x plus 1. And then they give us this factor here. So we can write those together to make f of x. So we will have f of x equals x plus 1, which we got from the graph, and x squared minus x plus 3, which was given to us. That's the factored form of the function. Okay, so let's look at number 8. Is there, oh, there is no number 8. All right, so that's it.